These plastic bags and hangers, for example.
What are you talking about, Oliver?
I'm counting the plastic products around me right now. I had a vague idea, but plastic is really used everywhere, isn't it?
Well, plastic is a very convenient material to use. It's not easy to come up with a substitute for plastic. So humanity will probably continue to live surrounded by plastic for a while.
Wow, so it's such an easy-to-handle material, huh? It makes sense why it's used in so many things. By the way, I wonder what exactly is plastic. There are so many plastic products in the world, but when you really think about it, it's hard to understand. It's hard to understand, isn't it?
Well, it's too familiar to even pay attention to.
Even though we just say plastic, the texture of a plastic bag and a hanger is completely different. I'm starting to want to know more about it. Can you explain it to me?
I got it. So this time, I'm going to explain what plastic is all about. Oliver, do you know what plastic is made of?
I think it's petroleum if I recall correctly.
Correct. Simply put, plastic is a synthetic resin made from petroleum.
Huh? So plastic is a resin? I never really thought of it that way. Come to think of it, what exactly is resin? Judging from the characters, it seems to have something to do with trees.
You're asking what resin is, huh? That's an interesting question. It's also related to the development of plastics, so I'll give a brief explanation about resin. A general term for resin, not synthetic resin, refers to the sticky substance or its solidified form that is collected from trees. Pine resin and lacquer are some typical examples.
Lacquer is used for high-end tea bowls, right?
That's right. Urushi is a substance that doesn't easily dissolve in water and has the property of maintaining its shape, making it a very convenient material to work with. By the way, lacquer is not only the oldest paint in the world, but it's also the oldest adhesive, and it's been in use for about 9,000 years.
I always thought of lacquer as something traditional, but I never imagined it was that old.
There aren't many materials as versatile as lacquer that occur naturally, so it has been highly valued since ancient times. However, lacquer, being such an excellent material, does have one significant weakness.
A weakness?
As can be seen from the fact that lacquer is mainly used for high-end tableware. It is difficult to obtain a sufficient quantity to be used casually, as it is a substance that is hard to collect.
Is it really that difficult to collect lacquer?
I think it's probably more difficult than Oliver imagines. You see, lacquer can only be collected after growing the trees for about 10 years. Furthermore, in order to induce the secretion of sap by injuring the trunk, we must consider the damage to the tree. It requires a certain level of careful work. When it comes to cutting down trees, you can use machines to simplify the process to some extent. However, when it comes to lacquer, you have to be mindful of the health of the tree and make cuts deep enough to collect a sufficient amount of sap. After that, you have to put the dripping sap into containers. It's a very time-consuming process. And you also have to be careful not to get a rash.
It must be tough to spend 10 years growing a tree and then go through the trouble of harvesting it.
Well, nowadays in countries like China, they have relatively simple methods for harvesting. In Japan, once the sap is collected from the lacquer tree, it's usually a one-time thing. We don't harvest after the first year because the quality decreases. In other words, we use a method where we harvest from a tree for a year and then cut it down. A method called kill and scrape. Even though we say we cut it down in a year, we continue to harvest for 4 to 5 months. So even though it's called kill and scrape, it's not about carelessly causing damage, so it still takes effort. On the other hand, in places like China, they sacrifice some quality to harvest sap from the lacquer tree every year, using a method called nourishing scrape. So recently, thanks to the supply from China, we've been able to get our hands on lacquerware that is relatively affordable, although the quality is somewhat inferior. It seems that lacquer tea bowls are even being sold for less than 1,000 yen nowadays.
Lacquer has always had a high price image, but if it's under 1,000 yen, it seems like even I can easily afford it.
Well, even so, lacquer still requires a lot of effort to collect, and the fact remains that it is a costly material. The cost of materials doesn't change.
I see.
Let's get back on track with the conversation, shall we? Lacquer has a very high functionality, but it has the drawback of being expensive. This is a problem that applies to other resins besides lacquer. That's why synthetic resins made from petroleum, which have the same performance as resins but are cheaper in cost, come into play. So basically, plastic was created. This is roughly a story from the first half of 1800. By the way, the name plastic comes from the property of materials like resin that can easily change their so it's derived from the word plastic, which represents plasticity.
Plastic was created with the aim of being a versatile resin that can be easily used, right?
It's fine if you see it that way. Plastic has been appreciated for its convenience and has been used in various forms up to the present. Over 100 types of plastic have been developed so far, and currently about 70 types are being used.
There are so many different types of plastic in the world, aren't there? I wonder what kind of plastics we encounter in our daily lives.
I think it's safe to say that almost everything with the word poly in it is plastic. For example, polyethylene is used in things like plastic bags and buckets. You might have heard the term poly bucket before. It's called that because the material used to make buckets is polyethylene. Another famous one is polyethylene terephthalate.
Polyethylene terephthalate? That's a name I'm not familiar with.
Well, the abbreviation is more well known. Taking the initials PET, it's often referred to as PET, like a pet. The word PET in PET bottles actually stands for polyethylene terephthalate.
Oh, I didn't know that.
So even the hoses and erasers are made of polyvinyl chloride, which is a type of plastic.
Oh, so erasers are also considered plastic. That's quite surprising.
Generally, the plastic we imagine is probably polyethylene or something like that. Plastic is a general term that represents a group, so it contains various substances.
I see. So even though we say plastic in one word, there are various types, huh? By the way, most substances with poly in their name are called plastic, right? I wonder what pori means.
You have a keen eye. Poly means many in Greek. In the field of chemistry, it refers to substances that are formed by many molecules coming together. In other words, polymers. For example, polyethylene is made up of more than 1,000 connected molecules of ethylene. We extract ethylene from petroleum and use it to manufacture polyethylene by connecting ethylene molecules together. On the other hand, substances like polyvinyl chloride are made up of many connected vinyl chloride molecules.
I see, I think I've got the general idea. So basically, plastics are made up of substances with names that come after poly and are connected together.
That's right. The conversation has been getting a bit long, so let's summarize it here for now. Resins like lacquer have stable properties and do not dissolve in water. They are high-performance materials. It had the drawback of being time-consuming to collect, so it was developed as a material that combines the functionality of resin with a lower cost and is suitable for mass production. It's a synthetic resin, in other words, plastic, and generally, the definition of plastic is it's a material primarily made from petroleum-based polymers, known for its malleability.
So that's the definition of plastic, huh?
Well, recently there have been new types of plastic emerging, so this definition is being reevaluated. I'll explain more about it later.
I understand. From our previous discussion, I learned that there are different types of plastic. But I wonder, what are the specific differences in the plastics that exist in the world?
Well, that's true, since the properties of plastic vary depending on the number of existent types. Let me give you a brief explanation about the general classification. But before that, let me explain the basic properties that apply to most plastics. Basically, plastic has the advantages of being lightweight and having the freedom of shape. In other words, it can be processed into any shape, and because of its lightness, it can be easily attached to various places. These two characteristics are major factors contributing to the prevalence of plastic products in the world.
It definitely seems very user-friendly, being easy to process and lightweight.
And plastics are divided into two categories based on their response to heat.
It seems like a difficult word.
Don't worry, I'll explain it in a way that's easy to understand. Thermoplastic resin refers to a type of plastic that becomes soft when heated and can be easily molded and shaped. On the other hand, thermosetting resins are plastics that, once heated and shaped, cannot be changed even if heat is applied later. If we were to compare it to sweets, thermoplastic resin would be like chocolate, and thermosetting resin would be like cookies.
What do you mean?
I think people who have made homemade sweets can understand it more easily, but While chocolate can be melted and reshaped multiple times, once cookies are baked, they cannot be remade even if you apply heat afterwards. Similarly, thermoplastic resin can be reshaped every time heat is applied, just like chocolate. Thermosetting resins, once heated, cannot be reshaped anymore.
I see.
There are many classifications for plastics, such as thermoplastic and thermosetting resins, but the list could go on forever, so let's stop here for now.
I got it. I was just thinking, have there been any groundbreaking developments in plastics recently? If there are any interesting plastics, I'd love to know about them.
I'm not sure if it's groundbreaking, but new types of plastic are still being developed. Biodegradable plastics and high-performance plastics are quite well known.
I wonder what those two plastics are made of.
Well, let me explain about biodegradable plastics first. In order to talk about biodegradable plastics, we need to understand the problems that conventional plastics have been facing. Conventional plastics are stable substances that don't easily break, even with simple actions. Konoshang funaksing zainutsuit, wuwaidi chinki dinis fingini sara sara rushang suya, dijong na donomunuchi kanai shunchustemo, and zixin shitbarasu shitukuji pin woshiyong dekirundaga. Erusmion karajing ruto, konosang tutuyo cruising zi adiona sutumuya imda.
A certain aspect?
Yes. From the perspective of environmental impact, it has a significant negative effect. It can take thousands of years for plastic waste to naturally decompose. I wonder if Oliver has heard about this before.
Yeah, I've heard it through the grapevine. Plastic waste is difficult to decompose even when buried, so there are limits to how much can be buried.
That's right. To add on, other disposal methods such as incineration and recycling also have significant environmental impacts due to current technologies. Plastic is a troublesome waste because there is no established effective disposal method for it.
I see. I was just thinking, why is plastic so difficult to decompose? What is the difference between materials that decompose easily and those that don't?
Well, you see, there are several ways in which substances can decompose, so it's difficult to describe the characteristics of easily decomposable substances in just one word. That's why I'll just explain the most representative ones. When a substance decomposes, it is generally broken down by microorganisms. To explain it in more detail, microorganisms consume the substances as food and break them down into other substances through metabolism.
So the decomposition of microorganisms is about their food, huh?
That's right. And the fact that microorganisms eat the substances they decompose means that they have to be able to survive in those substances. They cannot survive without them. Well, if microorganisms can't survive, then of course we won't be able to eat either.
I see.
So, whether a substance is easily decomposed or not depends on whether microorganisms can survive in that substance. And in traditional plastics, microorganisms have a hard time surviving.
Why is that?
Well, it's because the inside of plastic lacks the essential element for living organisms to survive, which is water. Plastic is hydrophobic, meaning it has a nature that makes it hard to mix with water. Substances that are easily decomposed by microorganisms, such as the foods we usually eat, not only contain water originally, but also absorb water when water is added. On the other hand, plastic does not contain water internally and does not absorb water even when it is added.
So basically, plastic doesn't naturally contain water, and it's not easily absorbent, right? That means microorganisms inside plastic can't get the water they need to survive. In other words, plastic is a harsh environment for microorganisms, which is why it's difficult to decompose.
You're mostly right with that understanding. But to add on, it's a little different to say that microorganisms can't survive in a harsh environment. In this world, there are microbes that live in extreme environments, like those dwelling in the vents of underwater volcanoes. There are also microbes that can survive in places where organic matter, the typical food for most organisms, is scarce. These microbes feed on metallic compounds. Theoretically, if a substance that can be broken down to produce energy has existed for a long time, it wouldn't be strange to find microbes that use that substance as food, regardless of what it is. Microbes have an incredibly high adaptability. There are microbes living in conditions that we humans can hardly believe are survivable. There are actually a lot more of them than you'd think.
It's amazing how microorganisms can withstand high temperatures in volcanic vents and even feed on metal compounds. If they have such high adaptability, it wouldn't be surprising if microorganisms capable of surviving inside plastic emerged. I wonder why there are no microorganisms that can decompose plastic.
Well, that's because plastic is a substance that humans have created, and it doesn't naturally exist in the environment.
Is it important whether it originally existed in nature?
Let me explain step by step. These microorganisms living in harsh environments have acquired the ability to withstand that environment over a long period of time. For example, microorganisms that can survive in a temperature of 100 didn't suddenly acquire the ability to withstand high temperatures. Initially, these microorganisms would die at 50, but over generations, their descendants are coughing, and by introducing a genetic bug, we could create a child with a body that can withstand temperatures up to 55 by chance. The descendants of microorganisms that can withstand 55 due to a fortunate genetic mutation gradually accumulate these small changes until they are able to withstand up to 60. It's like a tiny, tiny building block that adds up, creating offspring that can tolerate higher temperatures. Ultimately, microorganisms capable of surviving in a 100 environment are born. Genetic bugs can occur by chance, and even if they do happen, they can have negative effects in that environment, of course. To be able to survive in harsh environments, it takes a long period of time for evolution to occur. In other words, to survive in the harsh environment of plastic that has emerged in the past 200 years, it's actually quite normal that there are no microorganisms on Earth that can decompose it.
I see. Whether microorganisms can decompose something depends on whether the environment inside that substance is suitable for microorganisms to thrive. It's important to know how long ago that substance was formed on Earth, right?
See what you mean? And it overcomes the disadvantage of being difficult to decompose, which causes a significant environmental impact. So it's biodegradable plastic.
Finally, let's get to the main topic, the discussion about biodegradable plastics.
Biodegradable plastics have a molecular structure that makes it easier for microorganisms to break them down. Unlike traditional plastic, it decomposes in just a few tens of days.
I remember hearing that regular plastic takes thousands of years to decompose. To shorten that to just a few tens of days is an incredible advancement.
I agree with that too. Even though they're called biodegradable plastics, some of them don't decompose in water. We will need to use it differently depending on its intended use, though. If biodegradable plastics become widely used, we will be able to use them without degrading our standard of living.
That's interesting, isn't it? By the way, I wonder how long biodegradable plastic has been around.
Actually, biodegradable plastic was discovered in the 1920s by microorganisms. The existence itself had been known for a long time, but it never saw the light of day until environmental consciousness increased.
Biodegradable plastics are substances that have actually existed for a while.
Sometimes, substances that were discovered once can be reevaluated after some time has passed.
I see.
Just to clarify, sometimes plastics made from biological materials are called biodegradable plastics. Technically speaking, this is incorrect. Even if it's derived from a biological source, materials like BioPET are not easily biodegradable.
So even if something is made from living organisms, there are still some things that are difficult for microorganisms to break down, right?
Well, humans do manipulate things during the processing stage. On the contrary, there are also biodegradable plastics derived from petroleum.
I didn't know that.
By the way, recently, corporate responsibility towards the Earth's environment has been increasing. In the future, there is a high possibility that the development of materials that are friendly to the Earth, like biodegradable plastics, will continue to progress.
I see.
Well, I don't think that all the plastic we currently have will be replaced by biodegradable plastic.
Why do you think that?
While it's true that the stability of conventional plastic causes significant harm to the environment when it becomes waste, substances that decompose in just a few tens of days, like biodegradable plastics, cannot be used for underground pipes or construction materials. So when it comes to disposable items like convenience store lunch containers, but when it comes to long-lasting materials like construction supplies, traditional plastics are not the best. I think it will evolve into a form of differentiation, you know?
Depending on its purpose, different qualities are considered superior, right?
Exactly. By the way, earlier I mentioned that the general definition of plastic is starting to crumble. Well, that's because the raw materials for biodegradable plastics are derived from living organisms.
Indeed, the original definition of plastic was that it was made from petroleum, wasn't it? I like the feeling that the world is moving in a good direction, with definitions changing due to technological advancements. Thanks, I've managed to understand about biodegradable plastics.
You're welcome.
I remember there's another new type of plastic being developed, right?
Yes. The other newly developed major plastic is a high-performance plastic. High-performance plastic is a type of plastic that combines high strength, heat resistance, low friction, lightweight, and chemical resistance. High-performance plastic is not only used in general industries, but also in advanced industries.
It's more functional than regular plastic, isn't it? But why is it so high performance?
There are various reasons, but one easy-to-understand point is that it contains additives like carbon fiber and other substances. In the field of materials engineering, it's common to enhance performance by adding small amounts of other substances. A good example in our daily lives would be steel. Steel is made by adding 0.4 to 2 carbon to iron to increase its strength.
I see.
It's obvious, but adding materials indiscriminately doesn't necessarily improve the performance of the material. So, researchers are coming up with various ideas to develop new materials.
What kind of ideas specifically?
In addition to adjusting the proportions of the materials used and the temperature at which they are melted, as well as the cooling rate, researchers are also trying various other methods. I'm focusing on the internal microstructures that change with these. Furthermore, even a slight deviation can lead to significant changes in performance, so delicate work is also required.
It seems like it's going to be really tough. Material development seems to take a lot of time.
Oh yeah. In reality, material development has always been a laborious and challenging task. Once we had a rough idea, we would painstakingly create materials and test their performance, repeating the process. However, recently, we have been able to predict the properties of materials to some extent before creating them. As a result, the efficiency of material development has been steadily increasing.
It's amazing how you can predict the properties of a material before actually making it. I wonder how you make those predictions.
Well, it's a prediction made using AI. AI has several strengths, but in materials engineering, it is particularly utilized for its ability to derive approximate answers, even when the principles are not fully understood. This means that AI can provide solutions without requiring a complete understanding of the underlying principles. I can find patterns from past data and apply them to solve problems. In other words, instead of creating materials and then testing their performance, by using AI, we can accurately predict the performance of materials before creating them. The actual process of creating materials is becoming more like a verification of AI's predictions. Despite the fact that AI's accuracy is still low, by adopting a flowchart where AI predicts, and then we create the material to confirm, the cost-effectiveness of material development has improved and the speed of development has increased.
AI is really making a big impact in the field of materials, huh?
Absolutely. By the way, the field of material development utilizing AI is called material informatics. With material informatics, there is a possibility of groundbreaking materials being developed rapidly in the future. I think it's worth remembering because it won't be a waste.
I see. I'll keep that in mind. Thank you, Emma. I learned a lot this time, too.
You're welcome. So, let's summarize this time. Generally, plastic refers to a synthetic resin made primarily from petroleum as its main raw material. Plastic was originally created to be a material that could be cheaply and mass-produced, with properties similar to substances like lacquer and resin. The fundamental properties of plastic lie in its lightweight and flexibility of shape. It is praised for its convenience, and approximately 70 different types of plastic are produced worldwide, supporting our daily lives. Materials with the prefix poly, such as polyethylene and polyvinyl chloride, are essentially all types of plastic. Nowadays, environmentally friendly biodegradable plastics, there are some highly functional plastics being developed with outstanding features.
I see.
That's all for today. Thank you for listening until the end. I'll continue explaining everyday questions like this. So if you're interested, please come and visit again. Well then, thank you for watching.
Thank you for watching.